Welcome to another discussion on geometry. In today's session, we are going to discuss another important shape, circles. Now, a circle is a curved shape in a plane which is such that it has points which are equidistant from a center. Now, let us familiarize ourselves with a few aspects of circle. This circle has center O. The distance from the center to the circumference is the radius for the circle, R. Here, the line CD is called the chord of the circle. It joins 2 points on the circle. 2 points on the circumference of the circle. When they join, we get a chord. The largest chord of a circle will be the diameter. Diameter will be 2 times the radius. Okay. Now here, when we join the point C to the center O and D to the center O, we get an angle COD. That is called the central angle. This curved shape CED is called an arc. This portion of the circle OCEDO is called a sector. The line FG, which passes through 2 points on the circle, is called a secant. And this line ITH, which touches the circle at a single point, is called the tangent. Now let us familiarize ourselves with a few properties of circle. First of all, let us look at a few properties of an important line within the circle, which is the chord. Circle is usually represented or identified by means of its center. Let us say a circle with center O and radius R. There is a chord AB. There is another chord CD. Please keep in mind, a chord is a line segment joining 2 points on the circumference of a circle. An important property of chords are equal chords are equidistant from the center. So the distance of this line segment AB from the center O will be same as the distance of this line segment CD from the center. Equal chords subtend equal angles at the center. This is another important property, that is this angle AOB, let me call it angle alpha, and this angle DOC, let me call it angle beta. These two angles will be same if these chords are of the same length. Equal chords subtend equal angle at the center. Equal chords will have similar arcs also. The arc AB and arc CD will be very similar. Another property of a chord is the line segment drawn the perpendicular from the center of the circle to the chord will bisect the chord. Look at this chord AB. I draw the radius perpendicular to this chord that will bisect the chord. That means AD and BD will be same. This is an important property of chord which we will use when we do a few problems in circles. Let's say we have a circle with center O. This angle is called the central angle. This angle is called the angle subtended by this arc angle subtended by the arc AB on the center, you can say that this angle, if I take this as x, this angle will be 2 times x. That is, the central angle will be twice the angle subtended by the arc on this side, on the same side. Another property of a chord is that all angles subtended by the chord on the same side of the chord on the circle are all equal. All these angles will be the same. Okay. Two important properties. One is, if you have this chord AB, let me mark one more point here. This arc ACB has an internal angle 2x, and this arc ACB subtends an angle x here. It is a very important property. The internal angle, the central angle 2x will be twice of the angle subtended on the same side. Another property is, if you draw different angles over here, the chord is AB. If you subtend different angles on the same side of the circle, same side of the chord on the circle, all these angles will be the same. Now look at this. Look at the quadrilateral ACBD. All the 4 points of this quadrilateral are touching on the circle. This is called a cyclic quadrilateral. In a cyclic quadrilateral, the sum of the opposite angles will be 180. That is a very important property. That is, angle A plus angle B will be 180. Angle C plus angle D will also be equal to 180. These are some of the important properties based on a chord of a circle. Now, another important line with respect to a circle is a tangent. A tangent is a line that touches just one point on a circle. Okay. Now, if you have an external point somewhere here, you can draw two tangents to this circle. Okay. If I have a point P here, if I say this is point A and this is point B, both these tangents PA and PB will be of the same length. You can prove that. I'm not spending time to prove that here. Just keep in mind, if I draw a tangent from a point P to a circle, I can have two tangents, and both these tangents will be having the same length. Now, from any point on a circle, I can have only one tangent. Okay. A tangent will be perpendicular to the radius drawn through that point. That is, if I have this as O and this is T, OT will be perpendicular to this tangent. Now that we know a few properties of circles, let us do a couple of problems. Look at this figure. I have a circle of radius 10 centimeters. It is given that this angle BOA is 45 degrees. BA is tangent to this circle from the point B. That means this angle is 90 degrees. The question is, what is the area of this shaded part? There is a small shaded part here. What is the area of this shaded part? We have a circle of radius 10 centimeters. The center is point O. I have a point B here. BA is the tangent. The angle AOB is given as 45 degrees. What is the area of the shaded part over here? A small area outside the circle, enclosed by the circumference of the circle and the two lines BA and BC. Now, if you want to find this area, the straightforward method is find the area of this triangle and subtract the area of the sector ACO from that triangle. Can you find the area of the triangle? We know that this angle is 45, it is given. This is 90 degrees. We know that the sum of the three angles of a triangle should add up to 180 degrees. That means this angle ABC, should be 45 degrees. This should be 45 degrees. This angle is 45, this angle is 45. What does that imply? That means this triangle BAO is an isosceles triangle. This is same as this. Okay? And this is 90 degrees. So this side is same as this side, that means this side is 10. Can you find the area now? The base is 10, altitude is also 10. So area of the triangle will be half into 10 into. Area will be 50 centimeters square. Half base into height. Now what about area of the sector? You know the area of a circle is pi r square. Circle is pi r square. We know the radius as 10, so pi multiplied by 10 square, we have 100 pi is the area of the entire circle. Now what about the area of this sector? Full circle is 360 degrees. This sector has the central angle as 45 degrees. What portion of the entire circle will be this sector? That will be 45 out of 360. How much is this? 45 into 2 is 90. 90 is into 4 is 360. So this is 1 by 8. So you can say that this sector is 1/8 of the circle. So area of the sector will be 1/8 of 100 pi, which is 12.5 pi. So what we want is this area will be triangle 50 minus 12.5 pi. This area will be 50 minus 12.5. Let us look at one more problem. We have an equilateral triangle of side 10 centimeters. You know what an equilateral triangle is? All the sides are equal. So all the three sides of this triangle are 10 centimeters. We have a circle around this, that is, a circle is drawn around this equilateral triangle. A circle is drawn inside the equilateral triangle also, touching the 3 point over here. So we have a circle circumscribing this equilateral triangle, and there is a circle inscribed in the equilateral triangle. What I want is find the ratio of the areas of the outer to the inner circle. Ratio of area of the outer circle to the inner circle. Now we had a discussion on triangles earlier. An equilateral triangle is a very symmetrical figure. All the angles are equal, 60 degrees. Each side is given as 10 centimeters. Okay. In an equilateral triangle, all the lines, important lines coincide. That is the median, the altitude, the angular bisector, all of them coincide. And they will go through a common point. This will be the centroid, the orthocenter, the incenter, the circumcenter, everything. If I call this circle as, this triangle as ABC, A, B, D will be the median of this triangle. Median means both the sides are equal. It will be the altitude also, that means this will be 90 degrees. Okay, this will be median, this will be altitude, this will be angular bisector, everything. For a median, there is an important property. The centroid will divide the median in the ratio 2:1. 2:1. This is an important property. The centroid divides the median in the ratio 2:1. 2 towards the vertex and 1 towards the side. Now this PA will be the radius of the circumcircle and PD will be the radius of the incircle. So the ratio of the area will be pi 2 square by pi 1 square. There will be some constant here which I am not taking. So the ratio will be 4. So the ratio of the bigger circle, area of the bigger circle to the smaller circle will be 4. Okay. So in this discussion we touched upon some aspects of important properties of circle, and we did a couple of problems related to the circle. Thank you.